Let's start with the order of mathematical expression. You know that we have something which is called PEMDAS. Second, das. Okay. So we start with parentheses, then exponents, then multiplication, division, addition, then subtraction. So if you have algebraic expression and you want to evaluate it, start with parentheses, then exponents, multiplication, division, then addition and subtraction. Let's move to the next point. You know that if we have an even number times an even number, like 2 times 4 equals 8, it gives you an even number. Also, if we have odd times odd, like 3 times 5 gives you 15, this is an odd number. But if we have odd times even, like 3 times 2 gives you 6, this is an even number. Okay, this is about the even and odd. Know that also if you have a positive number multiplied and a positive number gives you a positive number, and a negative times a negative gives you a positive number. But if we have positive times negative gives you a negative number, negative times positive gives you negative numbers. The same in division. If you have positive divided positive gives you positive number. If you have negative divided negative gives you positive number. Negative divided positive or positive divided negative gives you a negative number. So let's move to the exponents. If we have something like that, x times x times x, or x plus x plus x. This is, we will add the exponents 1 plus 1 plus 1, which equals 3. So this is equals x raised to the power of 3. But x plus x plus x, this is equals 3x. If we have x raised to the power of n times x raised to the power of m. If we have the same basis, write it down and add the exponents n plus m. For example, if we have x squared times x raised to the power of 5, it will be x raised to the power of 7. As you know that, we will add 2 plus 5, which equals 7. Also, if we have x raised to the power of m divided by x raised to the power of n, gives you x raised to the power of m minus n. We subtract the exponents. For example, if we have x raised to the power of 7 divided x raised to the power of 5, it will be x raised to the power of 2. You know that x raised to the power of 0, this is 1, and this is x raised to the power of 1. And if you have x raised to the power of negative a, this is 1 over x raised to the power of a. Okay, let's move to another type of for radicals. Yes, if we have the nth root of x raised to the power of m, we have a rule for that, inner over outer. So it will be x raised to the power of m over n. For example, if we have the 9th root of x raised to the power of 2, so it will be x raised to the power of 2 over 9. This is about the exponents. Let's move to the consecutive numbers. If we have 3 consecutive numbers, let the first number be x, the second one it will be x plus 1, the third it will be x plus 2, then x plus 3, and so on. But if we have consecutive, even or odd, if the first number is x, the second one will be x plus 2, the third it will be x plus 4, then x plus 6, and so on. This is for the even or the odd. Okay, you know that if we have a perfect square like that, x plus y all squared, this will be x squared, second squared, which is y squared, then 2 times first times second, which is 2xy. Also, if we have x minus y all squared, it will be x squared minus 2xy plus y squared. This is the perfect square. But we have something which is called difference between two squared. Difference between two squares, like x squared minus y squared. This will be 2 brackets. Take the square root of the first, it will be x and x. The second also, it will be y and y. Negative positive. For example, if we have 4x squared minus 16y squared, this is equals what? Two brackets. Take the square root of the first, it will be 2x and 2x. The square root of the second, it will be 4y and 4y. One of them is positive and the other one is negative. This is negative and this one is positive. This is about the difference between two squares. What about the sum and the difference between two cubes? If we have x raised to the power of 3 minus y raised to the power of 3. Also, if we have x raised to the power of 3 plus y raised to the power of 3. Small bracket and a bigger one. This sign is always positive. Put the same sign. Put the same sign. Then put the opposite sign, so it will be positive. Then put the opposite sign, so it will be negative. Take the cube root of the first, it will be x, then y. Also, we have x and y. The square root of the first, so it will be x squared, y squared. First times second, it will be x times y. Also, this one, it will be x squared minus xy plus y squared. This is the sum and the difference between two cubes. We have something which is called quadratic formula. If you have a quadratic equation like that, ax squared plus bx plus c, this is equal 0. We can use factoring to solve this kind of equations. Also, we have something which is called quadratic formula. So if we have an equation like that, we can solve it like x equals negative b, positive or negative, the square root of b squared minus 4ac over 2a. This is the general formula to solve the quadratic equation. Let's move to the percent. You know that in the percent we have percent over 100. This is equals part over whole. Whole always after of in the question. Part maybe before or after is. Before or after is. This is part over whole to find the percentage of anything. To find the percentage of profit or the percentage of loss, if you want to find the percentage of profit or the percentage of loss, we have a rule times 100 to get the percent. Big minus small. Big minus small. In profit, put the smaller number in the denominator, but in the loss, put the bigger number in the denominator. This is about the percentage. Then we will move to variation. In variation, we have two types. One of them is called direct variation, and the other one is the inverse variation. We have two rules for the direct variation, also two rules into the inverse variation. For the direct variation, we have y equals kx, and k is a constant. And the rule is the second one, it will be y1 over y2. This is equals x1 over x2. The inverse variation, we have y equals 1 over kx. This is the equation of the variation, and also this is the equation of the direct variation. And also we have a rule y1 over y2. This is equals x2 over x1. This is in variation. So we have a rule in fractions. If we have a over b plus c over d, two different denominators, just we will multiply b times d, then multiply a times d plus c times b, or b times c is the same. For example, if we have 2 over 7 plus 3 over 5 cross 7 times 5 equals 35, 2 times 5 which equals 10, and 3 times 7 equals 21. Then add 10 and 21 which equals 31 over 35.